Carbon, right in the middle again. Remember carbon? 4 bonds, 4 baskets. Silicon, 4 baskets. These guys, 4 baskets. Lead, did you ever notice that lead is in the same group as carbon? PbO2, CO2. Huh? In beginning chemistry, they want you to memorize the compounds, but you got to know the electrons or how this does it. Remember, every bond is a pair of electrons. So if you have 4 bonds for carbon, these must be double bonds to the oxygen. 4 hydrogens, these are single bonds. CH4, that's methane. SiO2, silicon is in the same group as carbon. So CO2, SiO2, silicon dioxide. That's quartz, sand. The most abundant element on the beach is going to be silicon. The most abundant that we breathe, CO2 for photosynthesis. Huh? See the similarity here? And then lead oxide. These are all 4 bonds, 4 baskets. It's almost a no-brainer, isn't it? Oxygen. This is the one I got to tell you, because when you're in beginning chemistry, they'll tell you oxygen is always -2. 2 baskets, right? Well, sulfur can do like you got O2 minus would be the ion, but bring the H's, H2O. You've got H2S. H2S is the rotten egg smell. That's hydrogen sulfide. Well, sulfur can also do SF4, 4 bonds. It can do SF6, 6 bonds. So again, you see the double character that these things can have, or triple characters, but it starts with the 2. So oxygen, -2. Sulfur can have how many? 4? How many you got up here? 2, 4, 6. Up here, 2, 4, 6. Selenium fluoride, sulfur fluoride. You see the trend? Picture the electrons as basketballs. 2 for oxygen, 4 for sulfur. And remember, they're in the periodic table because they bond the same. Up and down, they react the same number of bonds, same number of valence electrons to make them stable. So I was saying, they say, remember, oxygen's always -2. Look at a hydrogen peroxide sometime. That's a little different. But for most general purposes, oxygen is always a -2. So nitrogen, remember I said nitrogen was 3. 3 baskets. What could be easier, huh? N3- would be the ion. If you bring the H's in for 3 bonds, NH3 is ammonia. So 3 for the nitrogen. Phosphorus has, if you remember the other chemistry, the lone pair opens up to give 2 bonds, so that's why it's 5. You got 3 with a lone pair of electrons for nitrogen, for ammonia. But phosphorus, if it did 3 bonds, would have a lone pair, say a chlorine, PCl3. Well, PCl5, you can also bring oxygens in, and this could form what would be a phosphate anion, or phosphoric acid. And the elements below it react the same. So we get the same numbers here. H3PO4. Looks like it's really complicated, but just picture. Phosphorus gets 5 baskets. So some of these H's are on the O's. That's what gets confusing. But you got to remember, 5 bonds. That'd be 1 double bond, 3 single bonds to 3 oxygens. It's the only way you'll be able to do it. So there aren't any H's on the phosphorus. PCl5, that's the equivalent of 5 baskets. It's the electrons. It's all related to the valence electrons. Are you getting it yet? Shoot the baskets, 3 or 5. Now this is a little twist I came up with here. And it's probably going to confuse you. If you got the way I just did it, don't even watch, okay? But this is another way for people that may not get it the traditional way. Okay, fluorine is going to take how many electrons? 1. So what is 1 point basketball? Stand at the free throw line, you make it, 1 basket, 1 point. Oxygen, remember oxygen was 2? So if you're at the top of the key, shoot it, 2 points, 2 electrons. Nitrogen, be out there in 3-point territory, right? So nitrogen's a 3-pointer, oxygen, top of the key, a 2-pointer, fluorine is a free throw. Now this might confuse you with the number of baskets last time. Now it's because you know better. We're just going to count the points. Oxygen, 2-pointer, 2 electrons. Fluorine's a free throw. Nitrogen with 3, that's the long bomb, a 3-pointer for nitrogen. Hydrogen needs to form 2 bonds to make a pair, so I pictured 2 electrons. It could be H2 minus, H minus, 2. H2, hydrogen, is like helium. So you need pairs, octets. Free throw 1-pointer, top of the key 2-pointer. Nitrogen's a 3-pointer. This is for those that didn't get the empty basket technique. Hey, it's Cosmic Ray, the quantum mechanic. I'm going to show you some new cool ways of looking at chemistry. Uranium 92, 92 protons. Throw a neutron in there, what do you get? It's still uranium, 92 protons. But you know what it does? It emits a high energy gamma ray, absorbs a neutron, and gives a gamma ray. So now what you end up with is 92 uranium. And it will spontaneously, if it gets a proton, that means that neutron had to get rid of what? An electron. They call it a beta ray. And the way that happens is when the neutron, a down quark, goes back to an up quark, less mass, so it's got to kick out some mass, which is going to be the electron, the beta ray. So now you've got a bigger element, so to speak, because it's Neptunium, 239. Weighs 239, but here you got a uranium 239. So you started with uranium 238, which was the mass. You added 1 more, made a uranium 239. And it gave out a gamma ray. So there's energies in just bonding and binding these things together. They call it a binding energy, is what the mass, its loss, is accounted for. But we're taking it a step further. You got to remember, the proton, the sleepy proton, is smaller than the bigger neutron. 2 downs in the up, remember? 2 ups and a down. Learn the quark theory. Protons and neutrons, all the elements are built from these. There's an abundance of neutrons in bigger elements. When you're smaller, it's an even. The magic numbers are even. 20 and 20 for calcium. 2 and 2 is 4 for the helium, right? Alpha particles, 2 protons, 2 neutrons. Up here, you've got 92 protons and a mass of 238. Subtract 92 from 238, that's the number of neutrons you have. There's a lot more neutrons than there are protons in uranium. So what'd you do here, Glenn Seaborg and guys at Cal? You shot a neutron beam into uranium, and you ended up with uranium 239. And what did the uranium 239 do? It decayed by emitting a beta particle, which is an electron. So you take the electron out of a neutron, it gives you a proton. So it increased the atomic number. That's why they'll call Neptune a bigger atom than a uranium. But really, think about it. Uranium 239 is bigger because the 239 neptunium, 93